In order to solve this equation, we're going to start by condensing this expression over here on the left-hand side into a single logarithm. So because of that addition there, we can use our properties of logs to condense it down into a single logarithm. And specifically, this would be using the product rule, as indicated by that addition. And so this condenses down to the log of x times x minus 3. And now we want to take our expression and rewrite it in its equivalent exponential form. So the base on this logarithm, since none is written, is understood to be 10. So we have 10 to the first power equals x times x minus 3. That's the equivalent exponential form of that equation. 10 to the first power is 10. We can distribute the x here. I'll go ahead and subtract 10 from both sides to get a 0 on one side. And then we can factor this. Setting each factor equal to 0 is going to give us two solutions. I get x equals 5, or x equals negative 2. Now we want to make sure and check those solutions in the case of a logarithmic equation, because our domain of a logarithmic function is restricted. We have to only plug in positive numbers into the logarithm. That doesn't mean I need to immediately eliminate the negative answer, but as I check these values, let's just make sure that we get positives inside our log. So I'll start with the x equals 5. Gives me log of 5 plus log of 5 minus 3. 5 minus 3 is 2. That's a good positive number, so that's a valid option. Using the product rule there, that's log of 10, and that's going to be equal to 1. That's true. So checking our negative 2, we get log of negative 2, and right away, I don't need to go any further. I see that I'm plugging a negative number into a logarithm, and so that part right there is undefined. So I can't even continue checking. So x equals negative 2 is not a valid answer. So our only solution there is x equals 5.